Okay, I'm just going to walk through the settings, what they call the function tree, but is really the settings map in both the manual and the installer/agent interface. So this is the function tree that you would see if you were pressing on the inverter itself. This is for the H1 hybrid and H1 AC inverter. So when you've got the inverter screen, you'll press the furthest right button, looks like a backwards button. That will cause the screen to light up. And then if you press any of the other buttons, or the check mark, which is, I think, is the third button, you will see these options: system. In fact, they're actually in a different order, I believe. I think it's system, settings, history, then about. But you'll find them. You can cycle up and down. I'll just draw on the screen a second. So you'll be able to cycle up and down by using the up and down buttons on the inverter. So this is a map that you'd have open when you were traversing the settings on the physical inverter screen. System is really an option that's just going to be showing you what's going on. So you can see battery information, what serials the batteries are registered with onto the BMS. You can see, I'm not sure you can see battery temperatures, but you can see basically the configuration of each of these elements. So for solar, you would see the PV1, PV2 data. The grid, you would see the power out and P grid properties, which are being taken from the CT clamp that you have around your incoming supply. EPS would be your EPS load, that's the emergency power supply or critical loads that drive off the battery if you have a power cut. And temperature of the inside of the inverter, and in the other there's two temperature probes within the inverter, so that's what temp does. History, I don't tend to use this one very much, but it's just a way of accessing the error log as well as some inverter yield data, and you can scroll through each property. Don't think there's a lot of point in going up to your inverter and looking at the history directly on the inverter. The cloud and the phone app does a far better job at giving you that information rather than looking at it, data point by data point on it. And about, you can see again the model, serial numbers, inverter versions, battery versions, IP address if you've got it LAN connected, and the MAC address. So most people are actually going to completely ignore almost all of this, and the only thing you're really going to be doing if you're touching the front of the inverter is this settings option. So press settings. It will then ask for a pin code. The default is 4 zeros, so 0, 0, 0, and on the actual inverter itself, you just press yes 4 times to end, because it's already preset to 0. And then you've got date and time. Pretty obvious what that is. Set the date and time, make sure it's correct. If it's wrong, and you're using time windows to do force charging, then those force charging windows are going to be wrong as well. Work mode, self-use, feed-in, backup. So do you want your house to use the power that's generated from the solar and then put any surplus into the battery before exporting it to the grid? Or do you want to feed in first, or feed in is cover the house load supply first, and then instead of charging the battery, it'll export down to the grid. So it effectively suspends charging the battery, and backup does the opposite. So the solar is powering the house loads, or just charging the batteries, but it's not going to do any export until those batteries are completely full, and then when they're full, it won't then discharge from the batteries. It's almost just hoarding power in the batteries if you expect there to be a storm. If you've got EPS set up for your critical circuits and you know that tomorrow morning you're going to have severe weather and you want to make sure you have a full battery for that, you could put it into backup mode, and that will stop the battery from discharging at all, and it will only be harvesting and charging based off the solar. Charge times are your force charge windows, or your windows that you don't want the battery to discharge at. There's another video that I've got on my channel for how to set up force charging windows and what to do if you want to stop your batteries from discharging, when you're charging your EV overnight for etc. Start and stop. This is pretty common if you're doing any maintenance work on the inverter. You can go into there and there's just two options to start and stop, and then you hit enter and it will do whichever one you've selected. I like to use the stop function to stop all the supplies before I then isolate the device. I just think it's a bit kinder to the hardware. Of course, if you isolate it, it figures it out and it stops anyway, but I just try to do my best to have a bit of mechanical sympathy for it. So start and stop. If it's a brand new inverter, you sometimes actually have to go in here and set it to start, because out of the box, sometimes they're set to stop. So you have to tell the system that it's good to now be commissioned and start. The on-grid settings, safety, that's where you'll be punching in your DNO code. So most of the inverters are going to be G99-1 or G98, depending on the inverter size and how it's configured. Export control, if you're using a CT clamp, you can put on here the maximum export. It's quite common for people to have large arrays but and a large inverter, but have a DNO restriction. So you might have 5 kilowatts worth of solar with a 5 kilowatt inverter, but the DNO, when you applied for export permission as part of your G99 application, have actually said, no, sorry, the local infrastructure can't handle that. We're going to limit you to 3.68, 3.69, 3.7, whatever they tell you your limit is, or lower. That's where your installer is going to set an export control. Sorry, here. This is going to set how much can be exported at any one time. The rest will be put into the batteries, or it will just start to throttle the solar production to make sure you don't go over that export limit. If you have a G99 or above with your generation matches your hardware, then normally this is set to something really high, like 60,000, which is kind of its unlimited mode. Power limit is power limiting the inverter. Haven't seen many use cases for this, but sometimes I've seen installations that have been put on wrongly sized circuits. So you power limit the inverter's capacity whilst the installer or the engineer is going to size up that MCB or the RCBO, that whatever the customer's got. It's just the ability to reduce the inverter's throughput. Again, not common. It's really about controlling the inverter for very specific reasons. These should really just be left to 60,000 for export control, as long as you've got DNO approval, and leave the power limit at 100. Power voltage frequencies, they'll pre-populate based on what your safety is set to, but normally it's 240 and 50 hertz. Grid parameters, that one I think is the actual grid details. I think that's the voltage that's coming from the grid. Whether you want to, and then off-grid is the next section on the menu, which is whether you want your EPS port to be energized in the event of a power cut. So there's an additional port on the bottom of the inverter that you can run critical circuits from. In the event of a power cut, that then becomes energized. You can also have it set so that it's always energized. There's lots of advanced functionality around the EPS port. It's quite complicated, and it's best to have a professional set this one up just to make sure that it's a safe installation. But that is whether you want the EPS port enabled. It's power frequency, again, normally 50 hertz, and the voltage normally either 230 or 240, depending on what you've got set up. Battery configuration. Maximum charging current, I think it's from 0 to 35 amps, and this is DC as well. So normally both the charge current and the discharge current, they're set to 35, meaning that you can have a maximum of 8 batteries on a H1 and utilize as much current for charging and discharging as the inverter permits. Very few reasons why you'd want to limit this. Maybe for longevity, charging current and discharging current, you can reduce those slightly down to 20 or 25 amps. That technically will reduce a little bit of additional strain on the batteries, but the benefits from being able to use the batteries versus pulling in from the grid kind of outweigh the additional wear in most for most people, depending on the rate that you're paying. But there is the ability to set the maximum charge, the maximum discharge rate of the batteries in amps that's DC. So not to be confused with that it's going to be trying to use 35 amps from your AC from your house, and you're thinking, oh, well, I've only got it on a 32 amp breaker. Maybe I should set this to 32 amps. That's not what this setting is for. This is the internal amperage between the battery and the inverter. Minimum state of charge, SOC. How low do you want the battery to be able to discharge down to? I think it comes out of the box at 20%. The battery hardware and the BMS support down to 10%. Most people will reduce this down to 10% so you can maximize the maximum depth of discharge of your batteries for that full 90% of depth of discharge. Charge it to 100%, and you can reduce it and use all the power down to 10% before the BMS is going to stop the batteries from discharging further. Maximum state of charge allows you to set the upper limit. The only time I've used this is when I deliberately wanted it to stop charging on past a certain point on a forced charge overnight. So I know it's going to be okay weather tomorrow, but it's not so good that I can get away with not having any forced charging. So what I can do is I can set this to say 60% maximum state of charge. It will charge it up to 60% during the forced charging window, and then stop it at 60%, and then wait for that charge window to go past before then starting to provide power to the house. And then even with this maximum state of charge set, solar still charges the battery. So during the day, the solar can still charge that battery, but I'm not using it to fill the batteries up. Another way around just leaving this at 100% is just reducing the time window that you're force charging. So if you know it's going to be okay weather, but you want a little bit of force charge, just force charge for half an hour or an hour instead of the full 4 hours if you're on an Octopus Go tariff. So they're really settings that you can manipulate to either affect the longevity of the battery. So it's a well-known piece of information that the shallower that you keep your charge and discharge, the better the battery performs. So, for example, if you discharge it only down to 20% or 25%, you will have more cycles out of that battery than if you discharge it to 10. Again, from everything that I've calculated based on the rate of the electricity costs, I think you gain more by using the battery down to 10% than dipping into the grid at those times. So it's the cost of the batteries and the wear versus the longevity of the battery. So really, for minimum state of charge, you should have it on 10 if you use the battery, and 20 if you want to be slightly more conservative. There is this on-grid minimum state of charge, and that allows you to set the battery's minimum to be, let's say, 30-40% minimum state of charge when it's on the grid, when the grid is working, so that if you have a power cut, then the minimum state of charge above takes into effect. So this one here. So min on grid means when the grid's connected and everything's working, how low do you want to allow the system to discharge the battery to? And kind of like a Tesla Powerwall, you probably want to be keeping 20-30% steady charge if you're expecting bad weather or a possible power outage. And then it's going to be the difference between these two figures then. So the power goes out, the min state of charge has been reached, and then it will allow it on the EPS to discharge all the way down to the min state of charge. Remote control, I haven't quite figured out what this one is. Haven't had any feedback from Fox support yet on this either, but it appears to be either capabilities of remote control either through the Wi-Fi dongle or remote control through maybe RS485 or the local LAN or something else. It's not clear exactly what this does, but it enables some kind of functionality around being able to control the unit. Again, as soon as we find out from Fox, we'll update this documentary and also update the document that a few folks on the group are putting together. The DRM0, it's not really used in the UK, but it's a way for the energy companies to send a piece of binary information down the power lines, so they can, in places like Australia, they're able to and I think they're doing it by using the frequency of the power. They're able to do binary data down to every customer's power connection, and the inverter is going to respect that. So the energy companies are able to tell inverters to stop producing so much solar, or start producing maximum solar, or stop producing solar at all. The various DRMO modes can be controlled either via a direct connection into the inverter, or by the inverter picking up this sort of remote signal in the AC connection. PV config is whether how the panels are arranged, whether they're independent or they're in parallel. Your solar installer will know what that means. Meter 1 CT is normally put. It's a CT clamp directly put around the live. So normally a white clip that goes around the brown live, with the arrow facing the grid, and that is so that the inverter can see the incoming power versus the generation, and it's able to do that sort of floating point management, so that the house runs off of batteries in the evening and runs off of solar during the day, and that it can force charge, and that it understands how much it's consuming versus feeding in. It's its only point of information about the energy that your house uses. So it's critical that the CT is positioned in the right location, positioned the right way round, and that it's that the wires are configured in the correct orientation. Sometimes installers will do that backwards, and then you'll have things like the batteries are constantly discharging to the grid needlessly. So CT1 is either a CT or a meter that is around your incoming supply. CT2 is designed for an alternative generation source, quite common for AC inverters to also have a standalone solar inverter like a Grow Watt or a Solace. So you can put a second CT around, again, the live coming out of that inverter facing the direction of the house, and that will be able to report in the FoxESS app how much power is coming from another source. It could be another solar source, it could be a generator, it could be anything. That's kind of your second power source. Bypass relay is to do whether or not you're waiting for an outside signal before you're switching the EPS on, or whether you want to use the internal relay and actually bypass the relay so that the EPS port is always powered. So if you're using an EPS system for critical load, critical circuits, you probably want bypass relay turned on, depending on your configuration, so that those circuits are always powered. Most installations will use a combination of a contactor and this configuration, depending on how it's been configured and set up. Again, speak to a professional before going into the EPS. It's riddled with regulation, and an incorrectly configured EPS circuit can be dangerous. Grounding is required, and that's what this option is. If you're using EPS, and in the UK, you're required to install an additional earth stake or screw. You need additional earths installed, and that's to protect the circuits. And instead of using the inverter's earth, which is coming from your supply, which most of them are CPC and neutral bonded, so that's coming straight out of your DNO, your distributor. Most modern buildings are using something called TNCS, and that's where your earth and your neutral are bonded. And then if you look inside your meter box, you'll see that the earth tail is actually coming out of your neutral, and then that's what's setting up for your house. If there's a power cut, there's a good chance that your neutral and your earth is then gone. So to protect yourself from having any kind of ground fault, if there is one, then you don't want to be in the middle of a ground fault. So you'll most likely have to install a ground spike or a pen fault monitoring device. There are a number of ways to do this, but ground spike is the most common. Again, speak to your professional installer to get EPS properly and safely configured so that it's in accordance with the regs. EPS overload auto reconnect. So that's if you've accidentally gone over the 5,000 watts capacity that most of these inverters have. It will trip and then it will wait so many seconds before trying to re-energize the EPS port. It's useful if your inverter is in a location that's not easily accessed. You're having a power cut, you've accidentally turned the kettle and the oven on at the same time. The inverter's tripped. If you turn one of those devices off, then it will power back up and stay on the next time it comes back on. Idle state, I'm still waiting for some information from Fox on this one. I have a suspicion it's when the inverter sees that the batteries are at 100% and the house load is low or non-existent. Especially important if you're using dual inverters. I think the inverter is able to reduce its idle power consumption, is what I think it's doing, but it's hard to tell, and there's no documentation. And everyone I've spoken to at Fox so far can't give me a clear answer, so that's probably one to follow up on. Communication, we're looking at Ethernet, RS485. This is the Ethernet port directly on the bottom of it. It's only used for connecting to Modbus and things like that. It's sort of a monitoring interface. It's not designed to replace the Wi-Fi dongle if you're using the Fox app. And RS485 is the protocol that's being transmitted on a couple pins on the COM port. If you're using something like a USR W610 to import data in real time into Home Assistant, you'll be using this bottom one, RS485, and in this option you actually set the Modbus port that's being used. Sorry, the RS485 port, and again with Ethernet, you'll be setting the Ethernet settings. I think it's got DHCP and a couple other options under here. And finally, around reset, it's whether you want to reset the error log, reset the yield, which is the stats about how it's all of the numbers about what the inverter's done, and a complete factory reset. So that's most of the settings. These settings, as you'll figure out, don't match one-to-one, especially the labels. They don't match one-to-one with what you see in the cloud options. And in the cloud, you actually get some additional options as firmwares have been updated versus this documentation. So if we go over now and have a look at the cloud, we'll just quickly go through what the cloud options are. Again, system time, year, month, day, hour, minute, second. Great, that's fine. Basic parameters 1, you can see how this maps to that function tree. Your grid code, language, PV setting, DRMO states, we don't use that in the UK. CT1, CT2 is disabled, my Modbus address. Password, I think that's the password for the inverter itself or the Modbus address. I haven't changed it, so I've not found that out. How often the Wi-Fi dongle is pushing to the cloud. 180 seems to be the default that it keeps reverting to, even if you change this. BMS set is a new option that was added for those that are waiting for batteries. So you can turn this off and clear it. And if you're waiting for batteries, but you have your solar, it will get rid of that BMS communication lost error. So it's great for people that are using hybrids or well, it's actually only hybrids because the AC ones don't have solar input. So this option only applies to the solar hybrids, H1s. If you have solar but don't have batteries yet, you would not plug your BMS in, you would not turn it on, and you'd be able to mark this as disabled, and then that would avoid it having the error whilst you're using it just for solar. It's quite common while people are waiting for batteries to come into stock. Work modes, we covered those. Self-use, feed-in and backup modes, that's there. Charging times is the forced charge windows. There's a far easier way to set these under the inverter options anyway, so I wouldn't normally bother with this. You can see here that from 12:30 to 3 o'clock, I have a forced charge window. Basic parameters 2, you can see here, here's the max charge current, the max discharge current, the minimum state of charge, maximum state of charge, the minimum state of charge on grid, the export limit sets its maximum, whether the system's on or off, the EPS frequency, whether the EPS is turned on or not, the output, the power limit of the inverter set to 100%, whether the bypass relay is turned on or not because of the EPS port, whether grounding's used, what the EPS voltage is, whether it's going to auto recover for overload, that sort of idle state mystery button. UPS output is uninterruptible power supply output, which is faster switching between when the grid goes down and it's switching over. So it will try to keep most devices online, even as it transitions between power and no power from the grid. There's a whole bunch of options here. I'll click on it. A lot of them are very specific for installers to worry about. The factory defaults, when coupled with setting it to G99-1, set a lot of these by default anyway. But I'll just click through them so you can see there's various limits, limit changes. A common one is this 10-minute average. That's a 10-minute high limit. That one trips occasionally for those that are around wind farms and other solar installations. So some people adjust this. Again, speak to your professional, speak to your DNO, whether you should be doing that or not. Safety features, frequency settings. Just wait for the system to load. There's nothing really else too interesting. All of this stuff is all, again, factory defaults is fine. Operation, whether you want to clear the errors, clear the energy stats, or do a factory reset, you can do all of that from this console. Battery voltages and battery temperatures, I don't think are used yet. Yeah, they're all appearing as -50, but these are new options that were added recently, so I assume there's some kind of extra functionality coming here. So between this, you can see all this functionality and this function tree where you're actually changing settings directly on the inverter. Hopefully that's given you some clarity. Most, if not all of these settings are all designed for installers and people that are competent in understanding what these changes do. So be careful not to change settings if you're not fully clear on what you're changing for what reason. A lot of this is behind the installer profile for a reason. And again, whilst you have access to it directly on the inverter, you can quite quickly put your system into a suboptimal condition, a dangerous condition, or prevent it working altogether. So speak to your installer. They should be the first point of call if you have any issues, you have any questions. Like I say, if you need to tweak anything for a specific reason, lots of knowledge on the group now with everyone doing all sorts of different permutations of install. But yep, that's a walkthrough of the two different ways to access these settings. Thank you.